is a small town, relatively small, east of Nairobi. It is predominantly and historically an industrial town. If you get to Thika, you most times as you walk through those roads, you're either likely to choke yourself of smoke, bad stench from poorly managed waste, or dust.
Our goal is to design an air purifier that is powered by readily available power sources and is affordable for our target demographic of teachers in Thika, Kenya. Our customers have a limited budget, so our goal is to create a product that could be purchased for less than around $170 or 20,000 Kenyan shillings. The purifier has to filter at least an 8-foot by 8-foot room by removing particles from the air up to 2.5 microns in size. We have created 2 prototypes to give customers more options when purchasing. The first is a square with a MERV 13 filter. The second is a cylinder with a HEPA and carbon filter. For the cylindrical prototype, there are 3 methods that can be used to manufacture the casing. First, the casing can be 3D printed. Second, the casing can be made out of recycled plastic, such as locally recycled plastic bottles using a mold. Thirdly, the casing can be made out of scrap sheet metal, which is readily available in an industrial town such as Thika.
Both prototypes have a filter, outer casing, power supply, fan, and motor. Where they truly differ is the shape of their outer casing and filters. The first prototype is the box model. Polluted air enters from the back, being pushed by the motor and the fan. This air gets pushed through the interior and goes through a filter on the other end. This MERV 13 filter can easily slide in and out to allow user replacement. The second prototype is the cylindrical model. Polluted air is pulled through the filter and exits through the other end. This filter stack contains a pre-filter, HEPA filter, and carbon filter to remove the most pollutants possible and avoid filter congestion. The design fan spins at a high speed, which results in efficient air exchange in the room. The final result is the same, but both models offer trade-offs for the user to choose from.
One of our major goals was to have a sustainable yet affordable product, and one of the issues we ran into in the beginning was making sure that our cost was low enough for people to want the system. So we ended up breaking it into 3 module systems. The first one is the most expensive, with a solar panel, a battery, and a controller. The second system is designed for users who already have existing solar panels, which is common throughout Kenya. And we connect up to the system using a battery and a controller, which cuts down on most of the cost. System 3 will be powered with a wall outlet and a watt meter. While this doesn't use renewable energy sources, it allows people with lower income to afford our product because it does not come with the solar panel and battery. The watt meter allows people to get an insight on their power cost.
Our affordable solar-powered air filter will have an immense impact on the community such as Thika, Kenya. The options available to use locally sourced materials and recycled plastics will both help the local economy and the local environment.